Okay. Yes, so my name is Örjan Östman, and I'm a researcher at the Swedish University of Agricultural Sciences. And I'm going to present work that mainly a master student, Niklas Niemi, has done. And it's important of reed, especially abundance and configuration on coastal pike populations. So reed has never been maybe rare or unusual, but has been always present in Baltic Sea archipelagoes. But due to increased nutrient loadings from land and in combination with decreasing grazing also along the shorelines, the reed belts have expanded quite much in the archipelago parts of the Baltic Sea. This has resulted in a decreased habitat heterogeneity, and we basically get more simple habitats with only reed habitats, and can affect biodiversity also, for example, for other macrophytes or other type of submerged water plants. Okay, as most of you know, pike is usually associated with reed. That you usually find them with reed. So this is not a story about how reed may have caused the decline of pike populations. This is more of can we manage reed somehow to trim the pike population to enhance the situations for the pike populations. So the basic idea here, or the background idea, is that if reed expands, we basically get too much reed habitat, and that may restrict the feeding conditions, for example, for the pike. So reed is very important for pike as a nursery habitat. But as they grow and become larger, they may need more open water, and especially the interface between reed and water can be important. So our hypothesis was that the pike abundance and the size structure of the pikes will depend on the configuration and heterogeneity of reed belts in coastal bays. So we did not go out and measure this ourselves. Instead, we used an existing database or field sampling, and it was from another project that actually was about evaluating spawning protection of pike and how that affected the pike population. It was from a project called ReFisk and organized by the county board in Stockholm. So they, through angling, surveyed 24 bays in the east of Sweden. It's the pink dots here. They're from around the county of Östergötland up to around Öregrund, where we sit. But most of them were in Stockholm County, these bays. They measured or they sampled information on the catch per unit effort, and that is the number of pikes caught per fishing hour. And they also measured the body length of each caught pike, and here we have used a body size indicator, which is called Lmax, which is the mean length of the 10 largest pike in each bay here. So it's a measure of how long the largest pikes in the population are. So it's just an indicator. You can use other, but I think this one was here. We try to focus on the large pike here. And what my master student did was to assess reed distribution and configuration from aerial photos. From these bays, he measured how much reed there were and how they were configured. So he developed a couple of what he called absolute reed abundance measures. So the total reed area in a bay, the total reed perimeter, that is basically the distance of the intersection between, or interface between reed and water. And he also calculated the average reed depth from the shoreline to the waterline. And I should say here that the shoreline here is taken from the Swedish Geocenter information. So it's nothing that we have measured ourselves, but it's a standard shoreline that we have used here. And then we also looked at some more relative measure. So it was reed coverage, like the percentage of reed in each bay. And then we have a measure that we call reed ratio, which is basically the parameter minus the coastline divided by the coastline. So it's kind of a proportion of how much longer the reed interface is than the shoreline. So a higher value means it's more complex interface between water and reed in this case. Yes, and I should also say, I realized I forgot to say something. This angling fishing or survey fishing was done during spawning, so it's during springtime. So it's only focusing from around mid-April to mid-May, or end of May this time. So it doesn't say anything about what pike do rest of the year. Okay, in general, all these reed characters were very positively correlated. So also it was a bit unexpected actually, but the more reed you usually had in a bay, the more complex the reed belt also was. So it was not only that I mean, we thought that if there would be very much reed, there would be more simplified or more homogeneous environments, but that was not really the case. So it's going to be a bit tricky to interpret the results since basically all characters are more or less positively correlated to some degree at least. The results are quite clear. So when we look at the catch per unit effort, there's a clear positive relationship between the catch per unit effort and reed parameter, and that is the total amount of or the total length of the reed per meter in the bay. We have in this graph here just split them up on sheltered and exposed bays. So there were in general more pikes in more sheltered bays, which is not unexpected. And then you can also see that there's a difference between these protected and reference areas, but I won't go much into this. This will focus on reed. But as you can see, both in sheltered and exposed bays, more exposed and less and more sheltered, there is a positive relationship. And somewhere around 2,500 meters of reed seems to be what is necessary basically to have some kind of a more stable or fixed or a high pike population. There are some bays here with very little reed, and you don't basically find any pike in these bays during spawning, at least. But when we looked at the body size, this Lmax indicator, you find the opposite relationship, that the body size generally decreased with the more reed parameter there are. And it's not evident that this actually was a density dependent effect. It's very hard to separate them, but when we correlated body size or Lmax with density, or catch per unit effort, it was not a significant relationship. So it might be actually some other behavioral or growth that make this difference with read parameter. There was also a weak relationship with the size and the read ratio. So read ratio was how complex the interface was between water and read. It's largely driven by one point here that has very simple interface or straight interface between the water and read, whereas okay, so among these more exposed, there is maybe a positive relationship, but there's a bunch of base here that basically doesn't show very much strong pattern here. But at least, yeah, maybe something is happening here. It's hard to separate what it is. So what we can conclude here is that read characters in absolute values seems to be more important than relative values for both the catch per unit effort and for the size structure. When it comes to the catch per unit effort, this might be that actually the more core habitat or something like that will kind of spill out or will act as a source for maybe less core habitat in these or that there's more competition or interference among the pikes in these core areas, so that also non-core areas may have higher pike abundances in this space. Of course, this is just a pure speculation. There is maybe also actually a sampling artifact that if there is they were fishing for a specific time, and of course the more reed belts there are, the more you can spread out the fishing, and if it's very little reed belts, you maybe actually saturate your fishing unintendedly. You fish one area for a longer time or so. It's that effect could be here, but also only the pattern with catch per unit effort and reed belts is sustained also when you're only looking at the larger base with most reed belts. So from this we see that the read parameter of around 2,500 meters seems to be important to have like some kind of stable pike population, and especially in the more exposed coastal bays. There was no tendency, or at least on pike abundance, that there would be too much reed that with the base with most reeds, that we thought this maybe prevent pikes from finding sources, or it's become too homogeneous. We couldn't find anything suggesting that. That doesn't mean that such an effect doesn't exist, but it remains to be seen. However, we found that the largest pike were associated were found in areas with less reeds, which I think is in line with what Henrik showed here, that in the more outer areas you more likely to find the larger pike there. Of course, we don't know if this can be density dependent or behavioral, but as Henrik data suggests, maybe it's most likely a behavioral effect. Okay, we couldn't find that there is too much reed, but these were natural reed belts, and we don't don't really know if we start experimentally increasing the parameter or the read ratio, that still may benefit pike population. So that is something that remains to be studied, because that could be a quite easy and cheap way to improve the pike populations if they are around at least. So we have some base where we have a reed management to increase the complexity of the reed belts and studied the pike populations there. And the preliminary results is that it's not a huge success. Pike population seems to be declining there, but so is the case also in a reference area there. So yeah, it's very uncertain, I would say. Okay, with that, I thank for your attention, and I'm happy to take any questions.